First of all, congratulate our student chapter for organizing this particular seminar, and thank the organizers for giving me an opportunity to speak before you. Why I just made the idea of proposal is, right now there is no subject called as supply chain industry. I would like such a subject to come in the industrial engineering curriculum. Of course, not at a BTech level. I am just proposing this particular subject at the MTech level in the post-graduation program. Now, right from the morning, right from Dr. Tushar Desai, we are discussing what is industrial engineering. Mr. Atik Desai also told what is industrial engineering. Professor Mohanty also told what is industrial engineering. Now, I am also starting from that particular thing, what is industrial engineering, so that I would like to say what is supply chain industry. To say what is supply chain industrial engineering, I would like to first of all explain what is industrial engineering. And this is my explanation of industrial engineering. Industrial engineering is human effort engineering and system efficiency engineering. Once again, you heard it. Industrial engineering is concerned with people. That particular point was told by Mr. Atik Desai, that industrial engineering is concerned with people, and that is what we are trying to say, human effort engineering. Right? The idea of human effort engineering is, in whatever engineering branch, if people are working, how those people should work will be designed by the industrial engineers. It can be electronics engineering, it can be electrical engineering, it can be chemical engineering, civil engineering, or mechanical engineering. In whatever engineering branch, if people are working, they are working. Right? That's what Professor Mohanty told us, that engineers create things. Right? In creating things, you are going to employ people as the operators or the workers, that sort of skilled people. Right? So that particular work of the human beings is designed by industrial engineers. The second point what I said was system efficiency engineering. This is where, once again, I will take from Professor Mohanty's lecture, where he said something like design adequacy. If you remember, he has shown three things, and one of them is called as the design adequacy. Now, once again, look at electronics engineering people. What do they design? Some electronic items. Right? Electrical engineering people. What do they design? Some electrical items or distribution systems, etc. Mechanical engineers, what do they design? Boilers, right? You know, machine tools, etc. Now, do you think industrial engineer design any of them? Industrial engineer cannot design boiler. Industrial engineer cannot design electrical generator. He cannot design a diode, right? Those items of engineering must be designed by only specialists in that particular branch, right? But industrial engineer is trying to increase the efficiency of the various designs. Right? That's what we are going to see once again in the next slide. So this is what is my explanation of industrial engineering. Industrial engineering is applicable in all branches of engineering. That point was made. It is applicable in hospitals also. That point is also made. So how industrial engineering is applicable in all branches of engineering in various business functions, it is applicable as an efficiency engineering. If you make a design of a system which is adequate, which is working, that system efficiency can be increased through industrial engineering techniques. Right? This is the point I am trying to bring it out by explaining industrial engineering as a system efficiency engineering. This is where the difference comes. A civil engineer, yes, he is going to construct a bridge, but that bridge can be made at a lower cost by industrial engineers. Because now I would like to show you, as I said, industrial engineering have two major components, human effort engineering and system efficiency engineering. What are the tools and techniques in the human effort engineering? So we start with the principles, right? When there is human effort engineering, there is something called principles of motion economy. Now, those are the principles you are going to apply, and you do something called as a motion study, right? This is where we are saying human effort. In any branch of engineering where a human is employed to give his assistance to the system through his using his hands or legs, etc. You are trying to do something called as a motion study, wherein the principles of motion economy are applied, and you are going to design how that man is going to use his hands and legs, etc., to create the design. Now in that particular thing, there is something called motion economy device design. It is simply jigs and fixtures, right? In the mechanical engineering, we have got something called jigs and fixtures. So when you are designing a jig or a fixture, what you are trying to do, you are reducing the work of an operator, right? Because you can quickly do the operation if there is a fixture or a jig is there. So that's why I am calling it as a motion economy device design. Then you have the work measurement. Morning also somebody said, at one point of time, industrial engineers are considered as the time study people who are taking a stopwatch and doing that particular activity. So we are calling it as a work measurement. Then, see what happened? Productivity. What is productivity? You see some examples. When a man is doing 100 items, you redesign the job and made him do 300 items. Now, when he is doing 300 items, is he comfortable or is he feeling some pain in his hands? Right? You have to see that particular thing. When the man is moving his hand, earlier 100 times, now 300 times. So what is happening to his comfort of the muscle? Now that is where we are talking about the fatigue and comfort studies, which have come into industrial engineering because you are increasing the productivity. Right? And then comes ergonomics is much more systematic. Whereas fatigue and comfort only look at one particular issue, ergonomics is a separate discipline, is looking at the man in the work environment. So various measurement related to man in the work environment, ergonomics people are doing, and you have to bring that into your human effort design, right? Because after when a man is working, he should not suffer any diseases. He should not have any occupational diseases. So you have to bring ergonomics into this particular. Then comes the job evaluation. Once again, Professor Mohanty said, what is the focus of industry at one point of time is fair day's job and a fair day's pay. Right? So industrial engineers, right from the day one, are concerned with this. If a man is producing more, he must get more income. Right? It is just not that you increase 100 to 300, you get the same salary. No. 100 to 300, if you increase the production, you are going to get more salary. To assure that, industrial engineers got into job evaluation and wages. So you are seeing some 7 or 8 techniques which you have listed in the human effort engineering side. Then we move to the next one, what we are calling as a system efficiency engineering. In this, once again we are trying to show there is something called a principal efficiency, which you are going to apply and increase the system's efficiency. Right? And the first thing we call it is a method study, which is studying the present method and finding alternatives to improve that particular method. Right? This is one of the important value engineering. This is what Professor Mohanty also said this particular thing. Now value engineering is what? Once somebody designs an item in any branch of engineering, right? That item is giving certain service, right? Now without disturbing the service, can I reduce its cost? This question was examined in value engineering, and even today successfully many times the costs are being reduced. If you go on internet, there are a number of examples in a railway coach, automobile, a road, a bridge. Many of these items from their initial designs, the cost is reduced by value engineering. So this is where I am talking of that. Any branch of engineering, there is an original design. That original design is investigated by industrial engineers and the cost is reduced. There is scope. There is techniques, there is a scope. With your focus on industrial engineering, you will be able to contribute to the company in terms of cost reduction without disturbing the earlier product's performance. Without disturbing whatsoever the performance of the earlier designed product, you will be able to reduce the cost. Now that is the power of industrial engineering techniques. Then we are saying engineering economics. Now what we are trying to say, engineering economics is not a specialty of industrial engineering. It should be told in each and every engineering branch. It is being told also. Now why it is being told is because in a company, already you are told, you have to earn profit. Business, you have to earn profit. In business, whatever you do, it should earn profit. So as an engineer, if you are going to do something, it should earn profit. So making a calculation and showing that whatever I am doing is going to earn the profit is a subject of engineering economics. When we do this subject, what we are doing, every expenditure we make is profitable. This is what we are proving, right? The same rule applies in the stock market. I am going to buy some shares today, hoping that after 1 year I am going to get a profit. Otherwise, you won't buy the shares, right? If you know engineering economics, you automatically know what to do in the stock market. There is a relation between, actually, in the book on economics books itself, in the engineering economics books, you are going to read something on the stock market. Automatically, the reading will come, because basically you are talking of a business must be profitable. So automatically in a business, you are going to evaluate whether in the future it is going to earn more profits or not. Right? Then we have something called as a mathematical optimization. All of you know, right? How to maximize a function, dy by dx is equal to 0. Right? That simple rule. The same thing we are talking here. Right? But in an engineering system, there is pure mathematics, dy by dx is 0. But now we are saying in this business, this particular function has to be maximized. Right? You are defining what is the function now. That's what Dr. Mohanty has done something. He said availability of the machine versus cost of running. Right? There are two opposing costs. You will be able to create a function and do that maximization. Right? Then we come statistics application. Right? What is statistics? You must be seeing what is the benefit of statistics. You can take samples, right, and can understand the whole population. That is the benefit of statistics. If 1,000 population people are there, I don't have to check all the 1,000 people. I can check 20 or 30 people, can understand the whole population. So you are saving the cost. Right? By taking only 20 as a sample, understanding 1,000, you are saving cost. So this is an application of statistics in the area of cost reduction. Right? Then we have WAR. Some of you have the WAR as a subject, right? Linear programming, non-linear programming, transportation problems, network problems. The WAR is basically developed to solve business problems. Right? Whereas optimization is more engineering optimization, WAR is much more into business problem solving. Then we have something called as a layouts. Layouts is how the machines are organized in or how this college is organized in various departments, etc. Right? The same point comes here, and we want to do something called as a layout efficiency study. We can increase the efficiency of layouts. Then we